In this video, we'll be finding roots of complex numbers. Every non-zero complex number has exactly n distinct complex nth root. De Moivre's theorem can be extended to find all nth roots of a complex number. For a positive integer n, the complex number a plus bi is an nth root of the complex number x plus yi if a plus bi raised to the n is equal to x plus yi. So that's just our definition. We did a super similar definition when we introduced square roots for the first time. So here's our theorem on how to find those nth roots. We're going to start with a complex number in polar form, r times cosine of theta plus I times sine of theta. To find the roots, we are going to take the nth root of our r value, that's out in front, but how we change the argument is a little bit more complicated than our previous operations on complex numbers in polar form. So the n distinct roots are given by the nth root of r times cosine of alpha plus I times sine of alpha, where alpha is going to be a couple different numbers. It's going to be equal to theta plus 360 times k divided by n, or we could write that, splitting it up into two separate fractions, theta over n plus 360 times k over n. This is how I prefer to look at it, where k is equal to 1, 0, 1, 2, 3, and so on, depending on what root we're taking. If we're going to work with theta in radian, then we're going to replace our 360 degrees with 2 pi. So this one, I think it's easier to understand it once we're actually doing one. The beginning part is easy. It's this part that's a little bit tricky. So let's find all cube roots of 27i. I'm going to start by looking at 27i in pure complex form, rewriting it as 0 plus 27i. This complex number is in rectangular form, but we need to get it in polar form so that we can apply our theorem. So we'll start by finding our r value. It's going to be the square root of 0 squared plus 27 squared. It'll be the square root of 27 squared, which is just 27. To find our theta, we're going to use the fact that tangent of theta is equal to 27 over 0. It's our y over x, which is undefined. Our tangent is undefined two places, at 90 degrees and at 270 degrees. We just need to figure out which one we want. So I'd take a look at the graph of this complex number. I'm going 0 in the x direction and then 27 in the y direction. So it's going to be right here, and that's definitely 90 degrees. So theta is equal to 90 degrees. Our polar form of this complex number will be 27 times cosine of 90 degrees plus I sine of 90 degrees. So now we want to find all the cube roots. So I'm going to start by taking the cube root of my r value. And we're going to have 3 answers here. Right? There's n distinct roots. So since we're doing cube roots, we're going to have 3 answers. We're going to start by finding the first one. This is when they say k equals 0. We're doing the cube root of 27 times cosine. This is where our formula, I'll rewrite it for us. All right, we get that alpha is equal to theta over n plus 360k divided by n. Well, our theta was 90 degrees, and our n is 3 for cube root. So that tells us that our first angle measurement is going to be 30 degrees. See, the second part doesn't play a role for us in our first answer because it's 360 times k, and for our first answer, k is 0. So we're not adding anything additional. We're going to get our first angle 30 degrees. Then, basically, what we're doing with this 360k divided by n is we're just trying to evenly slice up that 360 degrees based on the number of roots we have. We have 3 roots. So this is 360 divided by 3, which is 120 degrees. So what we're going to do to get our second and third cube root is we're going to be adding 120 degrees to our argument. So when k is equal to 1, and I'm going to do some cleanup with this here eventually and rewrite it in rectangular form. I just want to get the 3 roots written. So again, we're going to have the cube root of 27 times cosine, but this time our angle is going to be 30 plus 120. So this will be the cube root of 27 times cosine of 150 degrees plus I sine of 150 degrees. To get our third one, I'm then going to add 120 degrees to my 150 degrees. Still starts the same, cube root of 27 times, this time it'll be cosine of 150 plus 120. So cube root of 27 times cosine of 270 plus I sine of 270. So you find the first argument by just taking your original argument and dividing it by whatever root you are. So cube root, so we're going to take that 90 and divide it by 3. That gives us the argument in our first answer. Then you simply take 360 degrees and divide it by the number of roots you're getting. So again, take it, divide it by 3, and then you just add it to get your next ones. Adding 120. All right, now we got to finish these up though. We want to write our answer in rectangular form. So let's do each one of these. Cube root of 27 is 3. So 3 times cosine of 30 plus I sine of 30. Distributing the 3, that'll be 3 cosine of 30 plus 3i sine of 30. And then we'll get our actual trig values here. This will be 3 times square root of 3 over 2 plus 3i times a half. Our first complex cube root is going to be 3 square root of 3 over 2 plus 3i over 2. And we've got 2 more to clean up. Cube root of 27 is 3. I think I'm going to do the cube root and distribute at the same time. So this will be 3 cosine of 150 plus 3i sine of 150. And then we'll get these exact values off the unit circle. This will be 3 times cosine of 150 degrees. That's negative square root of 3 over 2. Sine of 150, that's a half. Our second cube root is going to be negative 3 square root of 3 over 2 plus 3i over 2. And then our last one, again, I'm going to do the cube root of 27 and distribute in one step. So this is going to be 3 times cosine of 270 plus 3i sine of 270. We'll get our exact trig values. Cosine of 270 degrees, well, that's 0. And sine of 270 is negative 1. Our third cube root is negative 3i. Let's try another one. We want to find all fourth roots of 4 minus 4i square root of 3. This time we'll just keep our answer in polar form. But to get started, we need to write our complex number in polar form so that we can apply our theorem. We'll start by finding our r value. Square root of x squared plus y squared. So that'll be the square root of 4 squared plus a negative 4 square root of 3 squared. So it'll be 16 plus 16 times 3. R is the square root of 64, which is 8. We'll find our theta value using the fact that tangent of theta is equal to y over x. Tangent of theta is equal to, this will be negative square root of 3. We know that tangent is equal to negative square root of 3, 2 spots, so we have to figure out which quadrant. And looking at our complex number, the x value is positive, the y value is negative. We're in quadrant 4. So the angle in quadrant 4, where tangent is equal to negative 3, that happens when theta is equal to 300. All right, so our complex number is 8 times cosine of 300 degrees plus I sine of 300 degrees. And we want all fourth roots. So for our first one, we're going to do the 4th root of 8, although we do the 4th root of 8 on all 4 of them. All right, our first angle here is going to be 300 divided by 4, because it's 4th roots. So we're dividing it by 4, and that's going to give us 75 degrees. So there's our first answer in polar. Now, to get the next one, we're going to add 360 degrees divided by 4. So one trip around the circle, 360 degrees divided by the number of roots, 4 4th roots. So we're going to be adding 90 degrees to each one to get our subsequent answers. So our second one will be the 4th root of 8 times cosine of 165 degrees plus I sine of 165 degrees. And then I'm going to do it again. I'm going to add that 90. So our third one will be the 4th root of 8 times cosine of 255 degrees plus I sine of 255. And then one more time, we're going to add that 90 degrees. We get the 4th root of 8 times cosine of 345 degrees plus I sine of 345 degrees. And those are our 4 complex 4th roots in polar form.